Hello learners, welcome to Let's Code. This is the very first video in this tutorial series, and throughout this journey, we will be learning data structures, solving interview problems, and building strong fundamentals together. So before we jump into writing codes or cracking interview questions, there is something far more important that we need to talk, and that is how to approach a problem. So how do we think about a solution? What step should we follow? What things should we check even before writing a single line of code? Because great developers are not defined by how many programming languages they know, but they are defined by how well they think and solve problems. In this lecture, we will build the foundation that will help you solve any coding problem, whether it's asked in interviews, competitive programming, or real world development. To solve any problem, whether it's a coding question or an interview problem, we should always follow a structured pattern. So I have categorized this approach into 5 steps. Let's discuss all of them one by one. So the very first step in the structured approach is understanding. So whenever you are handed out the problem, you are given the problem, or you are seeing the problem in the screen, or maybe the interviewer asked you the problem. So the very first thing you'll be doing the understanding. Okay, read out the entire problem statement. Don't skip examples or notes. Don't assume anything. Understand the problem completely. There should be zero confusion before moving ahead. Okay. If you have already seen this problem somewhere else, maybe in your practice while you were practicing, or maybe in your previous interviews, okay, there might be some difference between that one and this one. So always read it out. Okay, because many bugs start not in the code but in misunderstanding of the problem. Okay, so make sure you understand it completely. And then check out the input constraint. This is very important. Most of the times, constraints decide what should be the time complexity of your optimal solution. Just by looking at the constraints, just by looking at the input constraints, you can figure it out. Okay. So this is the first step, understanding the problem statement. All right. Then comes the next step, that is thinking before coding. So let's write it down. Think before coding. Now, what most beginners do, they rush to write code. We will slow down and understand why we are doing each steps. Break the solutions into steps. Write what you would do logically. Write in plain English. Okay. If you can explain your solution step by step in words, you can always convert your solution into code. All right. And while you are thinking, think of any edge cases when you are following the steps. Some of them are very common, which you can remember. Some obvious edge cases you can always think of, or create a checklist of them, like empty inputs, single element inputs, mean value or max values, duplicate cases. Like some problem could be solved very easily if there is no duplicates. Okay. Then boundary cases, like for the array problems, the edge cases are the the first element or the last element, the overflow cases, right? Overflow cases, the underflow cases, or null inputs. So these are the edge cases you should always think before writing code. Okay. Why? Because most bugs live at the edges, not in the middle. All right. So this was the second step. Now let's talk about the third step. That is starting the solution with brute force approach. All right. So let's write it down. Okay. What that means is when you are writing the code, it is not always possible that you will get the optimal solution. Sometimes you can, but sometimes you also can't. So the clever way is starting with the brute force approach, then optimize it. Okay. Start with the most obvious approach that is coming to your mind. Don't worry about the performance initially. You will figure it out step by step. But start at least write the any solution which is coming to your mind. Okay. Why? Because a correct solution is far more better than a fast and wrong solution. Okay. So at least start with a solution that is working. All right. Then comes the fourth step, that is optimization. So let's write it down. Optimize, just optimize. Okay. So when you're optimizing, how should we optimize the code? We will discuss about that one. So when you have written the brute force solution, check for any patterns or semantic observations which you can find. Okay, maybe you can use those patterns to write a clever code. Check for repetition. Is there any repetition? Can you remove it? Check whether you can store any of the result which you have already calculated, and maybe you can reuse it later. So check for such cases. Check if some steps can be removed completely. Some steps may not be contributing anything toward the solution. So you can remove them. Then check if any of the loops can be directly omitted using some maths formula or some clever way. Okay. Then choose the right data structure. This is a tricky part, but you can do it by asking yourself, like, what do I need to do? Is there any fast lookup? So when we do fast lookup, what is the best data structure that comes to mind? Hash map, right? So you can choose the hash map when you need to do fast lookup. Similarly, if you need to work on ordered data, what you can do? A tree or heap. Okay. Similarly, if you need to access some element sequentially, what data structure will you choose? Arrays or list, right? Because good data structure choice can cut your complexity directly in half. All right. So this was the fourth step, that is optimization. Now let's discuss about the final step, that is dry run your solution. Okay. So the fifth step is dry run your solution. Okay, what is meant by dry run your solution? Basically, when you have done writing code, done optimizing it, you must verify your code by applying the solution with a sample input. Okay, test with sample input, test the edge cases, and walk through step by step. Then, when you have done that, you will get the output from your solution. Verify that output with any of the examples. All right, you can just take the example input and verify with the example output. If it's matching, and then only you hand over the solution to the interviewer. If you can dry run it, do not submit it. Now let's apply everything we have just discussed and solve a very basic problem. Okay, the goal is not to rush into coding, but to understand how we approach a problem logically. So let me just fetch the code and write it here so that you guys can also see problem one. Okay, so hopefully this is visible to everyone. So the problem statement says, given a list of numbers in an array A, find the third largest number, add 1 to it, and return the result. If resulting number cannot be stored in an integer, return -1. For example, 5, 3, 9, 1, 6. So the third largest number is 5, add 1 to it, which is 6, and return the answer. Okay. Also, the constraint is also given for this problem. Let me copy this as well. So this is the constraint given for the problem. So the constraint says size of A can be up to 10 to the power 9. Okay, from 0 to 10 to the power 9. And any element of an array of this array could be from 0 to 2 to the power 31 minus 1, which is the integer range, maximum integer range from 0 to the maximum integer range. Okay. So I hope this problem makes sense to everyone and it is clear. Okay. So after reading the problem statement carefully, we can start thinking now. Okay. So what is required? Find the third largest number, add 1 to it. If result exceeds the integer range, return -1. So before solving the problem, there are a few important questions we must clarify with the interviewer, or we can check in the problem statement somewhere else too, or maybe check in the example. So you should ask these questions first. Do you think there is anything missing in the problem statement? Should we ask anything to the interviewer? Think about it. So the problem statement clearly says return the third largest number. What if an array has fewer than 3 elements? What will be written in that case? Also, what if duplicate number exists in the input? Right? What should be written then? How should we deal with duplicate numbers? So when I say what should we do when there are duplicate numbers in the input? What I meant by that is, so let's say there is an array input like this: 5, 5, 5, 5, 5. All the number are same. Or if there is an array input like this: 1, 2, 3, 4, 4, 5. So if you see in this case, all the numbers are same. So do we have a third largest? We don't, right? If we think in terms of distinct unique numbers, then there is no third largest. All the numbers are same. So what should we do in that case? Should we return the third, fifth? I mean, should we return just 5? or should we return something else? Or if we check the second case, here also the first largest is 5, second largest is 4, third largest could be either 3 or 4. It's ambiguous here also. So what should be written for such case? You have to clear these questions with the interviewer. Okay? Interviewers knowingly don't provide these details in the problem statement and expect you to ask these questions. Okay? Asking them shows your senior level thinking. These cases may look very small, but they change the entire logic. As I just told you, right? For those two inputs, there is ambiguity what to return. That is why we should never assume. We must clarify them before solving. Okay, we should not assume anything. Now, if we check the input constraints, so what is given here? The array size is 10 to the power 9, right? And from 0 to, the array element can be from 0 to 2 to the power 31 minus 1, which is basically int dot maxval. So the maximum value an integer can hold. So these are the two constraints, right? So now, if we think carefully, what does the first constraint mean? It simply means we cannot sort the array. Why not? Because if we sort it, it will take at least n log n time. That is the minimum sorting complexity, time complexity, right? And for inputs as large as 10 to the power 9, it will throw time limit exceeded error. Why that will throw time limit exceeded? We will discuss that part in a separate section today only. But we cannot sort this array. That means this immediately eliminates the brute force sorting that we were thinking previously. If someone was thinking that if we can sort it and then find the third element, append one to it, and then return it, that approach is failed. So we must think differently. Okay. So if we look at the problem statement again, what this says, it says here, find the third largest number, right? Can we try to use this to optimize our solution? Think about it. That simply means we don't need all the numbers. We only care about top three largest number. So instead of sorting the entire array, we can just track only these top three variables, right? Also, now we since need only three variables, we do not need any special data structure to store. We can just use three regular variables, three simple variables, right? So I hope this process is clear to everyone and it's very simple. So if everyone is clear, let's try to write the logic in simple words, in plain English. Okay? So let's write the logic. So now, before writing the logic also, let's try to think the edge cases. We already discussed it. So first edge case is if size of array is less than 3, right? In such case, most probably the interviewer will say to return -1. Why? Because there is nothing else to return. Also, so another edge case is if it does not allow duplicate and asks, and the interview tells you that return the distinct third element, then it is also possible that we do not find the third largest, which we just saw right here for this input. There is no third integer, third largest integer, even though the array size is less than, I mean, greater than 3, right? So this is also an edge case. Other than these two, is there anything else which we can think of? Any edge case? There is one more edge case which is already given in the problem statement itself. So the edge case is here. If the resulting number cannot be stored in an integer, return -1. Well, some programming languages may allow to store variables in any field which can hold very larger numbers also, but in most of the programming languages like C++, Java, Swift, Kotlin, that does not allow to store larger number. Like if any number is exceeding the declared type, it will be any garbage value, any invalid value, right? If you add 1 to it, it will not be any valid value. It will be something else, right? So that is also an edge case. So we have three edge cases and we know the steps. So what are the steps? Steps is first, if check. So now let's try to build the solution step by step in plain word. Okay. So first check if a dot size is less than 3, return -1. Then second thing we need to do is we need top three variables. So we'll be initializing three variables. So we will declare three variables to store the top three number. Okay. So initialize three variables, say x equal to, we will initialize all the variables with the lowest number so that if there is any number, we can compare it and it will be larger. X equal to -1, considering this is the largest, then y equal to, sorry, -infinity, and y equal to also -infinity, considering it the second largest, and z equal to -infinity, considering it as the third largest. We have to return the z. Then once we have declared the three variables, declared and initialized the three variables, we need to iterate through all the elements A for, let's say, n, basically for all the elements, let's say n, and we have to check for cases, check for cases as below. So what are the cases? If n is greater than the largest, then what do we have to do? We have to, so if n is greater than the largest, then we have to update the largest element. Before updating the largest element, we have to make sure that we shift the largest to second largest and second largest to third largest. So basically that means is we will have to do z equal to y. So push the second largest value into third largest, push the largest value into second largest, and push the new value, which is the largest, into the largest, which is x equal to n, right? If then there, then if this is not the case, then if n is greater than y, which is n is greater than the second largest, then we have to push the second largest value, which is, we have to push the second largest value into third largest, which is z equal to y, and assign the this new value to the second largest, which is y equal to n. Third case is else if n is greater than the third largest, which is z, then simply assign z equal to n. So we are considering the distinct three largest element case and not considering that there will be duplicates. Okay. For the duplicates, we will solve it separately. That will be very similar, but slightly different. Okay. We will talk that approach as well. But first, let's talk about when there are no duplicates. Okay. Now we have done iterating all the elements and storing the largest, second largest, and third largest. Then what will the next step? So the next step is also very simple. Since we are checking for unique largest elements, if z equal to minus infinity, that simply means there was no third largest. We have to return -1, right? If that is not the case, then comes the another edge case. If z plus 1 not within integer range, then also return -1. This is already given in the input only, right? I mean the problem statement only. Else, this is the final case, return z plus 1, right? I hope this approach makes sense to everyone. We have covered all the edge cases and we have done it using a single loop without sorting it so that it does not run into time limit exceeded. And that's it. We are simply returning the third element and appending 1 to it. And all the cases are satisfied here, right? Now we can discuss about the case when interviewer says, yes, duplicate is also allowed and we do not want the distinct case. We just need to return the third largest element, whatever it be. So here it will be 5 first largest, 5 second largest, and 5 third largest. So you have to return 5 plus 1. And here largest, second largest, third largest, return 4 plus 1. Right. We can also achieve the same by just tweaking simple bit. Instead of checking n greater than x, n greater than y, and n greater than z, we can just do n greater than equal to x, n greater than equal to y, and n greater than equal to z. That will solve the duplicate check thing as well. Okay. So now we have the process ready with us. You can just turn this code, turn the steps, turn this algorithm into code. That is very easy. Once we have this part, conversion is the easiest part, right? So I will leave that writing code to you. It's very simple. You can try it. Now, the last and the final step is dry run your code. Before submitting the solution, you must dry run and verify that it is working. Okay. So we have the example input and we have one special case for the duplicate case. So we will try for both these inputs and then we can submit the final solution. Okay. So let's dry run it. So here only, or let me just dry run in a separate sheet. Let me name it dry run. Okay. So what was the input here? It's 53916. Let me write it. 53916. initially initialize everything with x equal to minus infinity, y equal to minus infinity, and z equal to minus infinity. Now, if we check the very first line of our step algorithm, it says that if size is less than 3, return -1. So clearly the size is not less than 3, so we will not return. Even for this input also, it's not less than 3, so we will not return -1. We will just go to the next steps with the initializing variables and doing the iteration. Okay. So first, it's in here. Is 5 greater than minus infinity? Yes, right? So what do we do when x is, when n is greater than x, we replace third largest with second largest. So we replace minus infinity with minus infinity. Basically, this will come here. Replace second largest with largest. Again, minus infinity with minus infinity, and replace the largest with the new incoming element, which is 5. Element will come here. Is 3 greater than x? No, right? So first, if will fail, it will go to the next else case. Is 3 greater than minus infinity? Yes. So what we will do? We will replace this with this. So here minus infinity will come down and it will be 3. Now the element is here 9. Is 9 greater than 5? Yes. So 3 will come down here, 5 will come here, and 9 will come here. Similarly, 1 is 1 greater than 1? No. Is 1 greater than z? Sorry. Is 1 greater than x, y, or z? No, right? So the element will come here. Is 6 greater than x? No. Is 6 greater than 5? Yes. So 5 will simply come down here and 6 will come here. So it's end of loop. Now if you see, we have the largest element as 9, second largest element is 6, and third largest element is 5. Now we will check for the edge case. Does the element exist? Does the third element exist? Yes, right? It's not minus and minus infinity. Now we'll check the next edge case. Is 5 plus 1 less than int dot max? Less than equal to int dot max? Yes. So this will be the answer, right? If we talk about this another input, which is 5, 5, 5, 5, and 5. Everything is 5. Once again, x equal to minus infinity, y equal to minus infinity, and z equal to minus infinity. 5, yes, greater than minus infinity. So it will be replaced with again minus infinity. It will come down, replace with minus infinity, and 5 will be copied here. Next element is 5. Is it greater than equal to? So next for this duplicate case, we check for less than greater than equal to. So is 5 greater than equal to 5? Yes, it is equal to 5. So what we will do? Copy here is minus infinity. I mean, simply it will come down here. This will come down here, and this will be replaced with the incoming 5. Is 5 greater than or equal to 5? Yes. Once again, the same case. So now 5 will come here. This 5 will come here, and this 5 will come here. Now the element is here. Again, the same case, again true. So now again, 5 will come here, top 5 will come here, and the next element will be pasted here. Last 5, again same, and likewise. So if you see, it's 5, 5, 5. Largest is 5, second largest is 5, and the third largest is also 5. Right? Is the third element exist? Yes. Is it less than int max? 5 plus 1, same thing? Yes. So we will return the value. Now, let's assume for the distinct case, if this was the input, so here, for the first case, 5 will come here. Or let's try to dry run it with the distinct case. This was for the when duplicate is allowed. When duplicate is allowed. And this is when duplicate not allowed. Okay. So for that, when duplicate is not allowed, if this by the case, so let's see what happens then. X equal to minus infinity, y equal to minus infinity, and z equal to minus infinity. First, we'll come to 5. Okay. Is 5 greater than or equal to minus infinity? Yes. So third largest element will be copied with second largest element. Second will be copied with the largest element, and the largest element will be copied here. Again, we'll come to the next 5. Is it greater than largest? No. Is it greater than second largest? Yes. Okay. So actually, there is one more case we just missed here. Instead of just checking greater than, we have to add one more check. If it's greater than largest or greater than second largest or greater than third largest, with additional check that it should not be equal to the previous largest. What I meant is, so this is actually a miss. So you see, this is what happens when you dry run your code, you will eventually find the bug. So for the duplicate case, if n is greater than x, do this. If n is greater than y, and here there will be one and not equal to x. It must not be same as the largest element. Similarly here also, and n should not be equal to x, and n should not be equal to y. So this will be additional check which is required when we are dealing with the distinct element. So that is what I was talking previously. Dry running is very important, right? I did not actually I forgot about this case completely. But when I started dry running it, I simply found the bug here itself, right? Which was missed here. So it is also it is also very necessary you to dry run your solution. So now when we have the correct algorithm, correct steps, is 5 greater than minus infinity? Yes. Also, is it not equal to 5? That is failing, right? So it will not go into this loop. It will go to the next else part. Is 5 greater than equal to minus infinity? Yes. Is it not equal to x? Again, false. So it will not go here also. It will come to the next 5. Again, is it greater than 5? No. So it will fail here only. Is it greater than equal to minus infinity? Yes. Is it not equal to x? False. So similarly, all the 5 will be go into the else case and it will fail, right? So eventually, our all the variable will remain same. 5 minus infinity, right? And when we will come to this case, if z equal to minus infinity, this will be true and it will be written -1. So that is how we will deal with both the case, depending on what interviewer says. When we ask whether duplicate is allowed or not, we will update our logic, right? So I hope all of you guys understood the importance of understanding the problem completely, asking cross question with interviewer, writing the steps in plain English, and dry running, right? I hope this made sense to all of you guys. Now, if you remember, while solving the last problem, we reached an important conclusion that for an input size as large as 10 to the power 9, sorting the array is not simply an option. Why? Because it will definitely throw an TLE. It means time limit error. Okay. And this brings us to something extremely important that every programmer must understand: why time complexity matters in real life. So let's now talk about performance. Time complexity, performance. So why time complexity matters? Not just in interviews, but in real world applications also. You can often hear term like linear complexity, exponential complexity, cubic complexity, quadratic complexity. They are time complexities, right? But what do they actually mean in practice? So here is the simple truth. A solution that works perfectly for 10 inputs can completely fail for 1 million inputs. Think of it like traffic. A road that works fine at midnight can become a nightmare during rush hour, like when office opens or office closes, right? Why? Because of large number of traffic or large number of vehicles. Algorithms behave the same way when the input size grows. Okay. So now let's understand what is DLE. DLE stands for time limit exception. DLE means you are writing correct logical code and compiles correctly but slow. So this is fine. This is fine. This is not fine. That is why the platforms forcefully stops your program and throws the time limit exception. So you might ask, how much time do platform gives? Most online platform gives you 1 second to run your program. And this is the most common scenario, right? Very rarely it can happen that it can give you more than 1 second, like 2 seconds, 5 seconds, or it can give you less than 1 second, that is half second or something like that. And this time is given per test file, not per test cases, right? So what happened behind the scenes? Your code is not running on your laptop. It runs on a remote server where the input size is very large and worst cases scenarios are tested, right? The platform measures CPU time executions. If your program crosses the allowed time, it will throw a time limit exception. So how is this time measured? Very simple. When your program starts, a timer is also started with it. And when it stops, the timer also stops. If the execution time, which the timer took, is greater than the allowed time, you will see it clearly. So why time complexity is so important? Because different algorithms behave very differently as the input size grows. So here's a very thumb rule that every developer should remember. In roughly 1 second, a program can safely do around 10 to the power 7 or 10 to the power 8 operations. So let me write it down. uh, most platform gives 1 second to complete one test file and it can do around 10 to the power 7, 10 to the power 8 operations in this. Right. So in 1 second, a program can have around 10 to the power 7 to 10 to the power 8 operations. If your program is taking more than 1 second time to execute one test file, it will throw an time limit exception. What are the reasons for a slow code? If you say for a slow code, we have already discussed this. If there is nested loops, if there is uh, unnecessary recursion or sorting, right? Or also wrong data structure or recomputation of the same thing. For such cases, a code becomes relatively slower, right? That is why we talked about thinking before coding. In that phase, we have to optimize our code and we have to check for such cases which can be removed from the code, right? So that our code runs faster and it can be accepted by the compiler and it does not throw the time limit exception. Okay. Now, when we were saying that in 1 second, CPU can perform around 10 to the power 7 to 10 to the power 8 operations, why don't we say an exact number that exactly this amount of person will be calculated or will be performed by the CPU? We cannot say that because it depends on various factors like the CPU speed, type of operation you are performing, the programming language you are using, the type of memory it's accessing, right? So all these things affect the operation it can perform within 1 second. Like most CPU operates in around 2 to 4 gigahertz, right? And 1 gigahertz means 1 billion cycles per second. So 2 to 4 gigahertz means around 2 billion cycles, right? 2 billions mean 2 to the 10, 2 into 10 to the power 9. But here is the catch. One operation is not one cycle. Sometimes memory access is also slow. And complex operations can take multiple cycles to perform one single operation. That is why we never assume that in 1 second, 1 billion operation will be performed, right? Like for simple operations like addition, subtraction, simple comparisons, or array access, like or increment, decrement. These things are simple operations which can be done within one CPU cycle. But there are some other operations as well which we assume as a single operation, but internally these are not single operations, like hash map access, recursion, floating point math, like when we add two floating point values, subtract the floating point values. or when we do string manipulations, right? At that time, although we assume these are just single operations, but these are not single operation in terms of CPU clock. That is why we never assume the number of CPU cycles equal to number of person number of CPU cycles equal to number of operation it can do, right? For safer side, we always assume that uh, in 1 second it can perform at max of 10 to the power 7 to 10 to the power 8 operations. Now I will give you a thumb rule which you can remember, and you can also expect the optimal time complexity for any given problem just by looking the input constraint. Okay, so here it is. So this is the thumb rule. If your if your solution is doing the work in order of one time, then it can have like any input, right? There is no constraint on it. If your work is done, if your solution is taking order of log and time, it can also accept very large input. If your code is performing an operation, then input size will range something around 10 to the power 7, right? If your code is taking n log n, your input size will be something around 10 to the power 6. Okay. If n square, then it will be something around 10 to the power 4. If order of n cube, then you can expect 10 to the power 2, or maybe a few hundreds, 200, 300, something like that. Right. If your program is taking more time than this, then either there will be some specific condition given that the input size will be either less than 10 or something like that. It will be a very constant value. It should not be very much. But in generic cases, where no such special thing is given, if your code is taking more time than this table, then it is probably your code is not the best optimized. You can further optimize it. So try to remember this thing. Okay. All right. So that will be all for this video. And this is just the beginning. In the upcoming videos, we will start applying this thinking to real coding problems, interview questions, and practical scenarios. If you want to build strong fundamentals and learn how to think like a developer, then you are already in the right place. Subscribe to Let's Code and let's start solving problems right away. Thank you.